Hello, everyone. Welcome back again to my class. And this class is a continuation from the class on objects in Java. So, a while ago, we discussed all those things in the screen. We managed to create attributes in our class hero, and we also create a functions to it to manipulate some attributes from our class. So basically, those are the behaviors of our class heroes. So one thing that I am going to correct for our presentation is, as you can see on our example, there are repeated instructions that um, we need to consider, and we have to also um, to update since we are on the object-oriented approach and we have to minimize codes for our coding. So as you can see on these functions like heal 10% and heal 20%, all of those codes are similar. All we need to do is just to the number of percentage that we tend to use. Okay, both of them are the same. So what if we will just create another one? We'll just create one functions that really um, do those things inside one function. Also, this one for basic attack and all the attacks, like for basic attacks and first skill, second skill, and third skill, although those are attacks, so probably we can for the mana deduction. So all of those are for mana deductions for whatever attacks that they have. So what happened is to subtract all the mana. So basically all of those things are the same. What we're going to do is to upgrade this code. Okay, so I will do not delete this file for us to have a copy for it. So all I need to do is to create another class inside our project. So inside for ITS 202. So I have here a hero, which is all this bunch of code. I'll be doing the same, but I'll start from scratch and copy some of the things I need to work with. So first is I will create another class and I will name to hero 2. So this is another thing from the other hero class. So I'll click finish. So I have now hero 2 class in here. So all this one is the same. So I'll just copy on it. Okay, and also I'll just copy also this one because I'll update some information for our hero. So my task for the first task that for this video is to use parameterized functions. Are you going back to their functions on our basic or in our visual programming? We can pass data through in the function through parameter. Okay, so like for example, on our hero, we heal. So we will just create heal. Okay, so double heal. So right now we do here, we submit data, pass data through parameter. So we will just accept um, percentage data that the user will give, okay, to the um, to this function. So we will just say double uh, percentage. Okay. So this one, so we create a, a variable inside of the parentheses and we call it we call now this function as parameterized function. So it is as a declaration of variable that you are telling the compiler that you are going to create a placeholder storage of data inside of this open close parenthesis. This one is the data type, and this one is the percentage. We can also set it to integer uh, for the percentage. Like for example, 10%, 25%. So what happened is we will do automatically use what is our calculation. Like for example, for the health, whatever the health times whatever the function. Okay, the percentage. Okay, so here we can just mana is equal to mana plus mana times the percentage. Okay, so since the percentage needs to have right integer, so we can just automatically use double for us now for really do some easy multiplication or arithmetic operation. So that one heal, no sorry, return mana. So to stop the error. So what is basically what it is when you access the help function, you need to supply or provide a data inside this parameter. Okay, so only have one data here. So that is we store it on our percentage. Whatever our percentage that we store, we calculate it on our mana. Okay, so another good thing here, there is a shortcut with this kind of coding or syntax. If you multiply or add the same variable, okay, we can use shortcut like this. Instead, plus equals, and we do remove that one. So this is shortcut operand for those long. So meaning it is equivalent to what happened earlier. Instead of writing mana plus mana, so you have to add here the arithmetic operator and remove that one. So that is automatically tells us that mana is equal to mana. Okay, mana is equal to plus mana, then the percentage. So we will try to look at this kind of codes, and we will try to pass 10%, 20%, and 30%. Okay, so first on a main function, we have all of those things for the class hero. I'll be creating another object for hero 2. Hero 2, my obj is equal to new. Okay, and hero. So I'll copy all of those things here for us to fast. Uh, we can type it fast, and instead of using obj1, you can use obj. Replace everything here. Okay. So I'll research some hero for ML to be exact. So heroes for ML. Sorry, for a while. So we need to create now a new hero. Okay, and we have those keys. So basically, we have a problem here. Probably what is the hero? Because the constructor, the default constructor is hero 2 since this is the hero 2 class. So we have to use hero 2. Okay, and okay, for a while I was searching for heroes that I have to use for my example. Okay, for a while. Okay, sorry for the long wait. Now I have now the list of ML play heroes. So I'll try to use Aldos. So code for Aldos is 64, and the name for that hero is Aldos. And the role for that is fighter. And we have also the specialty is that is burst and support. Okay, for a while. Okay, that is fighter and burst, burst and support. For a while, I have my laptop um, is loading. So burst and support and expert in laning, expert laner. Released year is 2018. Okay, and the mana for this one, health will be 200 and mana is, for example, 150. So we have now a new character or hero in our program. We managed to create a new object from our hero. Okay, the one here is from class hero, which is the old one that we have a while ago. So as you can see, we have a lot of repetitive things na itong buhat kaniya, especially on our hero here, where there are many functions, our codes are repeated. So we need to change it. So by the use of the parameterized function. So right now, if we will heal this hero, for example, since the maximum health for this hero is 300, so we have to heal it 50%. So all we need to do is, okay, first is to output this hero, my obj that introduce hero. So you output that one, and we output the current health, system out that print line, the current health. Okay, then we output access it. So by using my obj that health. Okay, so we know that our health is 200. Yes, 200. So we have um we will change, no, so since our health, so our we need the maximum health for this one is, for example, is 300. So we will make it max it, we will try to max it using this function, which is health. Okay, so health regen, we will use it, health regen na lang. So health regen, so all we need to do is use the health regen. So system out again that print line, since that is not a void data type, it's only a return type, so we need to output it or in order for us to see the result. So the health after regime, so my obj dot health region. As you can see right now, we can use the health region. You can see that there is a double percentage, so there is a data need to put in here. Okay, so the data for that is we can use point 40, for example. So we will increase our health region to 40%. Okay, so that's it, and then run our program. Okay, so hi bang bang. Okay, hi bang bang. Okay, you have listened new. My name is Aldos. My hero code is mobile in Mobile Legends 64. My role is a fighter. My specialty is bursting and support. I am an expert laner, so I was released in 2018. The current health 200. The health after regen, because we use the regen function. The health is now 10%. Okay, ni-regen na siya into 40%. Okay, so that's it for 40% ba? That is actually correct. But before that, I will create separator after this, before this obj system out that print line. Okay, that's enough for our separator. So based on our calculation, I'll go back to hero 2, or whatever our mana set is add plus the percentage. 40% of 200 is 40% of our 200. So if you have this to have 200 times 0.40, so we have 80. Supposedly we have 80. And so that means that is 280. So what happened? Mobile. Okay, since we have a problem now, since we health our health is health region, not mana region. So we are concentrating with the health. So sorry for that. So that is health, and that is health, and also that is health. So return health. So that is my mistake. Sorry for that. So save it and go to the main function. So our expected output for this one is 280 for our health. Yes, we have our health. Since we increase our health into 40%, then that makes it 80 to 80. Okay, so if you want to regen it again, so what makes it? Okay, so it makes it, if you will duplicate this one, it will makes it to plus 300, because it's now basing 280 0.40% for 280. So it will now add to 280. So we have 392, because this is now the base of 200. Okay, so you can always add of your mana region, but the last data that we region is not the 200 but the 280, because that is the now the current value for our mana. Okay, so we manage to our solution is to manage to lessen our codes using the parameterized function. The same as well as for mana deduction once you do special attack, right? So we can perform like um, double mana deduction. So we deduct mana through physical attack, basic attacks, first skill, second skill. Okay. So we can do some transferring of data to parameter. Okay, first here, um, double here. First parameter, because we will create four parameters for this function for us to really understand also that we can put list of parameter, a list of variables inside the parameter list. So double, and this one is BA, basic attack, or we can have basic attack. Okay, and the separator is semicolon in the parameter list. So double, basic attack. Okay, then another one, double. Okay, first kill. Okay, first first kill FK. Okay, first kill. Then third one is double kill or second skill SK, and the last one is the third skill or the SS, special skill SS. So all of those we have to supply for data when we use mana deduction. Okay, so if you do that one, so we are just in one mana deduction, we are going to concentrate, okay, on what are those things that we have to uh, subtract for mana deduction. So for mana deduction here, we can just directly subtract mana deduction. So what is your mana? Okay, mana, and then we can use mana is equal to, okay, basic attack. Okay, minus FK minus SK, sorry, minus SK minus SS. So then don't forget to return mana. So we subtract all the mana for everything if we use basic attack or first skill or a special skill and special skill. So that is everything will be deducted for mana. So the same thing that we do here in the previous one, but you can see a lot of codes are being used and repetitively. So in here we do simple subtracting all of those to mana. Okay, but this is wrong because it now subtracting from basic attack subtracting to that one. So all we need to do is to perform it. We will always deduct it from mana. So I am wrong. I am wrong with this one. So to do that, we will use mana for subtraction always. Mana for FK, mana subtract by SK, mana subtract is equal to SS. So everything that we put all for basic attack, first skill as special, second skill and special skill. Okay, SS. So it will be deducted all of those from mana. Okay, so in here, when your hero will do some attack, okay, like for example, system out that print line. Okay, so the mana after the mana after the attack. Okay, So before we have to print the mana. Okay, system out that print line the mana before the attack. Okay, before and after. So that is mana. So we access the mana by using my obj that mana. Okay, no, that is yes, that's correct. Mana. So we access it. So what is the default value? And then right now we use the mana reduction. If we do some attack, my obj that mana reduction. So you have to supply for data inside the parameter. Okay, first is the basic attack. So right now I am just using basic attack, and my basic attack of this hero is 5. Okay, that is the 5 less than. And this one I don't even use the first skill, second skill as SS. So I just put it only to 0 and 0. So that said, so we have now created our first attack, and this is only basic attack. Why basic attack? Because first parameter. Okay, since this is the parameterized function, we are now 4 parameters inside this function, so that means we have 4 data to pass. Okay, the first data that we pass is 5, and that is intended for basic attack. Second data to pass on the parameter is intended for the first skill, and third data is intended for the second skill, and the fourth data is for the special skill. Okay, so right now I need just to attack a basic attack, and then your basic attack based on your calculation that is only 5 mana regen deduction. So what I had, so when we output around our program, we can have an output like this. Mana before attack we have 150, and mana after the attack. Okay, you can use after the basic attack, we can change it to basic attack. So from the basic attack, okay, so we set it. Okay, so subtracted it by 5. Also we can also create another one, so we can use the this one for our codes is not being repeated, but uh, as you can see we have a short codes but always repeating. If you want to work on it, no, mas nicer siya compare ganiya, compare ani. We have a lot of codes that are being repeated here. We only have 3 functions at the total. By the use of parameterized function, we tend to eliminate some redundancy of duplication of codes. So right now, for example, you attack mana after the basic attack. Okay, I'll just put it here for you to recognize. Okay, so I'll just manage to pop up so that you can see the codes, entire codes. Right now, mana after the basic attack and first kill. So right now, it's you know that basic attack is 5. Then your mana is deducted to, for example, 20 for your mana regen. So all the is 20. So that means that this attack is will consume 25 mana. So from 145, it will be deducted to 25. So probably the answer for this one is 130. So when you run it, the mana skill is 120. I sorry 120 because it's deducted by 20 man. So 20. So from 145 to 20 because we use basic attack and the first skill. Okay. So that one. So if you want to another attack, okay. So you can also use after the basic attack and first skill, and we will also include and okay second. So I'll just to make to save space. And second, skill. So here we can use the second skill consume 50 mana. Okay, so you can use yes, since mana basic attack first, so for this three combo, so a total of mana of 75. So 120 subtracted by 75, so siguro we have only um 45 remaining mana. Basic attack, I have now 45 remaining mana from 120 subtracted by 75. Okay. Okay. So the same thing for mana regeneration. We can just do that one. On our hero to mana deduction. Okay. Then we have also double mana regen. So the same thing. Um, we do some double for our data type and whatever the percentage, and then also the we can use this one the same here, do double percentage, and here instead of health we use mana we use mana for that. So we do mana routine. Okay, so like for example, since no if you're really doing game and you especially you can found it on the in the map where you can see mana routine for example 100% mana routine. So out of your mana your mana will be fully recovered for 100%. So that means so you can just here system out that print line. Okay, so uh, mana regen uh, for 100%. So use the mana regen function from our object, no? My obg dot mana regen, and what is your percentage, for example 100. So remember that our mana is 45, so it will just add times 2 lang na siya. It will become 90 for our case. The mana is 45, 45. Okay, as you can see, 45, 45. Why? Let's see why it is doing that kind of calculation. Because whatever the mana plus equals times percentage. Okay, so the same. And what mana reaching 100. That is so 45. That is 45 and 45. So plus equal to 45. Yeah, return mana. Yeah, but we have a problem. Reason for is yeah we don't have the calculation. Margin is 45, 45. So that means it will just automatically add. Yeah, so 8 times 100. So probably have a problem here when they do that. So I forgot that that is percentage, so we put here that Okay, we put that here. So again, so as you can see, it now double. Okay, so as you can see, 100% of the mana. Okay, second is 45 right now. It turns to 49. Supposedly it will turn to 90. So probably our calculation is wrong. Whatever the mana, okay, whatever the mana is times 100%. So we can see the calculator for a while to check our calculations. 45.0 times 0.000100. So we have 4.25. That is the 100% of 45. So we have a problem with our, that is why when we add, we have 49. So we want that it will make it 1, so 100%. So that is 1%. So basically, when we do that one in here, we don't want 1.100, but we use 1 only. Okay, because that is 100%. Okay, 1 only, because 45 times 45 is equal to, as a whole, 45 plus 145. So basically, when we use 100%, we just use the whole, one number, whole number. So run. Yes, that's it. So 100%. So from 45, you origin it for 100%. So meaning, i-times 2 lang niya ang iyang health. But basically on the game, if you are trying to get a mana regene, like for example, because it depends on, the potion that you you found and you put into your character. So for example, like Inani, for example, it will just times 2, or just not the same as 100%, but regene for, times 2 for the mana, current mana, times 2 for the current mana. So probably that's the correct one. So you times 2 the current mana, so you can, have that that idea. You can mana regen for times 2. You can also, if you found another region that also times 2, so that's times 2 now, 90 times 2, so it makes now 180 for mana region. So that is 180. So that's basically, our my objective for this course, for this topic, is to use parameterized, function when we see, some which is duplicate data. So before I left, I see also there is the same function, double health region and mana region. We have similar code construction, and it is make our code, we call it our code much more, uh, long. So we can do, or we can eliminate those things, and we will just, siguro, we will solve this one. So we can use double region, and here we can select string, like what are the type of region. So we have string, okay, we have type, right? String, region type, and also, double, percentage. So to eliminate those redundant data, So percentage. So right now, okay, okay, then output. Okay, so the return is regime. Okay, so right now, all we need to do is to type or declare int regime, and okay, we have a local variable initialize. Okay, so it's okay since on Java. So right now, all we need to do the region there. Okay, so region. So if type is equal to um, mana. So if that is a mana, I'll use mana. Okay. For a while, since we have to set and also get the value for that. Yeah. So we when mana plus equals um, mana times percentage. If that okay, else if type is equal to health, so um, mana sorry health plus equals health times percentage. Sorry, health. Else, okay, okay. Region equal to 0. So right here also I'll use region since this is double, so I'll change it to double. And double is equal to sorry, region is equal to mana, and here um region is equal to health, and we will return region. So by these things, we can now really remove this one. We will omit, and also we will omit. Uh, okay, so I'll just move it forward in here. So I can have here region. So meaning right here, instead of using mana, like for example, mana region, health region, I'll use region. And region, and then what type? Like for example, that is health, and use parameterized comma. Okay, the same with here. I'll just copy and paste. Okay, it helped. Okay, my object. And here for mana region, it's now still region, but this now mana, and this now I need to use one. The same thing for this one. Okay, so that's mana. So whatever here that we input, we output here, it's always the same when we run it. The same. It's from 150 mana to subtracted by 145, and then for first skill, okay, first skill and attack base attack per skill minus 25, so we have 20. Then another another one, 20. Basic attack second skill subtracted by 75, so we have 20, 45, and we double the mana from 45, and we also double it from 90. So we go are okay for mana. For the health region, we have a problem. Health, since we have the problem since we type it in a capitalized one, and our here is low, small, so that is not the same thing in Java. So it's case sensitive. The small letter H and the big letter H is not the same. So right now that is what our problem a while ago. But right now we can now do the same. We increase our health to 40%, and also here for 40%. So the same. Okay. What is the things that we change? The same output, but the kind of codes that we have bring in our class is what we call neat and nice. Instead of having from these repetitive functions that gives you about 66 line of codes. So from now at 66, we can now remove it. For example, this one, because that is only para. So from 66 now, we can now have 46 or 48. So we managed to lessen our codes uh, using the parameterized function. So I guess that's my presentation for this part 2, for us to resolve redundancy and to also to experience lighter codes in our class. We use some sort of parameterized function to solve it. So thank you for watching. I hope you learned something with my video. Expect for the part 3 for this series of class and object in Java later on. So again, bye bye. Keep safe everyone. God bless.